everyone. I hope you're all doing well. Today we're going to continue Module 6, and we're going to discuss solution concentrations and reactions. So section 9.4. Now, let's say we're creating a solution where we're going to dissolve 8 grams of potassium iodide in 42 grams of water. Now, potassium iodide is present in a lesser amount, so that's our solute, and water is present in a greater amount, so that's our solvent. Now, how do we express the amount of potassium iodide in water? Well, we're going to express that as a concentration. There are multiple different types of concentrations, so there's different ways that we can express how much solute is in a solvent or in a solution. So let's learn about some of those different expressions. Now, in general, the concentration of a solution is equal to the amount of solute over the amount of solution. And sometimes that's the amount of solvent. It kind of depends on what you're calculating. But in general, this is what the concentration is equal to. Now, the amount of solute can be expressed in different units, depending on how you measured the amount of solute. So, for instance, maybe you were able to weigh the solute. You could express the amount in grams. Or maybe it was a liquid, so you measured the volume. You could express the amount in milliliters. Or maybe you converted grams to moles. You could express the amount of solute in moles. And then the amount of solution can be expressed in different ways as well. So we could weigh the amount of solution, which would give us grams. We could measure the volume, which would give us milliliters or liters. Now, you could also figure out how many moles of solution you have, but that's pretty complicated, and you're not really going to do that until you get into general chemistry. So we're going to use these different units for now. Okay, so the first type of concentration is called a mass percent concentration. So mass percent is abbreviated as M over M, and the mass percent is equal to the mass of your solute in grams over the mass of the solute plus the mass of the solvent in grams. Now, when we add the mass of the solute to the mass of the solvent, what we're really ending up with is the mass of the solution in grams. Because remember, solute plus solvent gives us a solution. So we're really just taking the total mass of both the solute and the solvent in the denominator. And then, of course, we multiply by 100 to get our percentage. And once we have a mass percent, we can also use this as a conversion factor. So let's say we're told that we have a 14% by mass solution of something. What we can do is convert that into a fraction. So we could say, oh, I have 14 grams of solute for every 100 grams of solution. So that would be our 14% by mass concentration. Or what if instead of 14, let's say we're told we have a 5% by mass solution of whatever. Then that means we have 5 grams of solute for every 100 grams of solution. So when you're given a percentage and you have to figure out the ratio of solute to solvent, just assume that, solute to solution, just assume that you have 100 grams of solution, and then you can just plug in the grams of solute from there. Okay. So going back to the first slide we saw, where 8 grams of potassium iodide was added to 42 grams of water. Oh, it looks like that changed on me. This says potassium chloride instead of potassium iodide. Okay, so let's say we're adding 8 grams of potassium chloride to 42 grams of water. Let's say we want to express that as a mass percent concentration. What we would do is we would take the 8 grams of our solute, which is potassium chloride, and then we would divide that by the sum of the mass of the solute and the mass of the solvent. So really this would end up as 8 grams of potassium chloride over 50 grams of solution, because 8 plus 42 is 50. And then when we plug that into our calculators and multiply by 100, we get 16% as our mass percent. So not too bad. So let's actually solve a problem here. Let's calculate the mass percent of sodium hydroxide in a solution prepared by dissolving 30 grams of sodium hydroxide in 120 grams of water. So if you want to try this on your own first, feel free to pause the video, and when you unpause it, we'll go over it together. Okay, so remember mass percent, M over M, is equal to the mass of the solute in grams over the mass of the solute plus the mass of the solvent. And then we multiply by 100. Okay, so let's just plug in what we know. Although first, let's figure out what is our solute. Is our solute sodium hydroxide or water? So it's sodium hydroxide because it's present in a smaller amount. So we're going to put that in the numerator. And then we're going to divide that by the sum of the solute and the solvent. Okay. So this will simplify as 30 grams of NaOH over 150 grams of solution. Okay, so I'm going to plug this into my calculator and see what we end up with. So we have 30 divided by 150 times 100. Okay, so I get 20% NaOH. All right, so this solution is or contains 20% sodium hydroxide. So just some simple addition and division here. And here are the solution slides. Let's do another problem. A solution is prepared by mixing 15 grams of sodium carbonate and 235 grams of water. Calculate the mass percent of the solution. And we have a multiple choice here, so we've got A, 15%, B, 6.38%, or C, 6%. So if you want to try this one on your own, again, feel free to pause the video and then we'll go over it together. Okay, so in this problem, again, we're going to take the mass of the solute and divide it by the total mass of the solution. Now let's first determine what is our solute. Is it sodium carbonate or water? So the solute is sodium carbonate. And then our solvent is water. All right, so let's calculate the mass percent. So we're going to take the mass of the solute, which is 15 grams, and then we're going to divide that by the total mass of the solution. So we want to add 15 and 235. Okay, so let's simplify that. So let's see, 15 plus 235, that's 250. Okay, so let's plug this into our calculators if you haven't already. So 15 divided by 250 times 100. Okay, so I get 6%. And that matches C. All right, now if you didn't get the same answer, one thing just to make sure of, did you add the solute to the solvent in the denominator? Because sometimes it's easy to forget to do that. I see a lot of people just plug in the mass of the solvent in the denominator and they forget to add the mass of the solute. So always remember you want the total amount in the denominator. Okay, and here are the solution slides. Now, there's another way that we can express concentration, and that's called volume percent. So the volume percent is very similar to mass percent, except instead of grams, we're going to use the unit milliliters. So we're just measuring the volume of the solute and the solvent. So volume percent, or V over V, is equal to the volume of the solute over the volume of the solution. So remember, you might have to add the volume of solute to the volume of solvent to get the total volume of the solution there. And then we multiply that by 100 to get our percent. Now, this is very similar to a mass percent as well, in that we can express this as a ratio. So let's say we're told we have a 20% volume concentration. We could write that as a fraction. We could say, okay, that must mean I have 20 milliliters of solute for every 100 milliliters of solution. So again, in this case, we're assuming that we have 100 milliliters of solution because this is a volume percent. And then we can make the assumption that we have 20 milliliters of solute. And very similar to what we did before. Okay. Now there's also a mass volume percent concentration, and this is abbreviated M over V. Now in this case, we have a little bit of a different calculation. So a mass volume percent, we're going to take the mass of the solute in grams and divide it by the volume of solution. Now, in this case, it's going to be difficult to figure out the total volume of solution just from the mass of the solute and the volume of the solvent because the units don't match, right? So typically in this type of calculation, we're just going to assume that the volume of the solution is the same as the volume of solvent. So this makes it a little bit different from the other two types of concentrations. So for the denominator, you can kind of ignore the mass of the solute. All right. Now, the reason we can do that is, for instance, let's say we have a beaker of water, and let's say the volume is 20 milliliters. And then let's say we add some salt. So maybe we add 5 grams of sodium chloride. Those 5 grams are going to dissolve, and they're really not going to have an effect on the volume of the solution. They're not going to increase the volume significantly. So that's why we can just say that the volume of the solvent is the same as the volume of the solution for this particular concentration calculation. Now, this does work the same as the other two concentrations in the sense that, let's say we're told we have a 10% mass volume percent. What we're going to do is assume that we have 100 milliliters of solution, and then we can say that for every 100 milliliters of solution, we have 10 grams of solute. So again, we just have to keep track of units in this case, because it's grams over milliliters, mass over volume. All right. Now there's one more concentration that we have to talk about, and this is probably the most important concentration, and that's called molarity. Now, molarity is what we often use in chemistry to express a concentration, so you're going to see this a lot. We do see the other types of concentrations, but not quite as often as molarity. So molarity is moles of solute over liters of solution. So those are the units there. And that's also shown down below. Now, molarity can also be abbreviated as just a capital M. So if you don't want to write out moles over liters, you can just write a capital M instead. All right. So as an example, let's say we're told that we have a 1 molar solution of sodium chloride. That means that we have 1 mole of sodium chloride for every 1 liter of solution. Now, let's say we had to make a 1 molar solution of sodium chloride. The way we would do that is we would weigh out 1 mole of sodium chloride. So that means we have to figure out, okay, how much mass is equal to 1 mole of sodium chloride. So I think from previous calculations, we found that 1 mole of sodium chloride is equal to 58.44 grams of sodium chloride. So that means we would have to weigh out 58.44 grams of sodium chloride. And then we're just going to add that to something called a volumetric flask. And this is what we typically use to make solutions because they're very, the volume is very accurate for these types of glassware. All right, so then once we add that amount of sodium chloride to our volumetric flask, then we add enough water to get to 1 liter. So that same mark is shown up above. So we're just going to add enough water to get to that line. And then, of course, we mix and make sure everything is dissolved. And then that would give us a 1 molar sodium chloride solution. So if we had a chance to make solutions in lab, this is how we would do that. Of course, we're online, so we can't, but maybe you can use stuff in your kitchen to make solutions. So let's do a practice calculation. What is the molarity of 0.5 liters of sodium hydroxide solution if it contains 6 grams of sodium hydroxide. Okay, so let's figure this out together. So we're given 6 grams of sodium hydroxide, and we'll assume that that is our solute. And we're told that we have a total volume of 0.5 liters of solution. Now what we need is molarity, which remember is equal to moles of solute over liters of solution. Okay, so we already have liters of solution. We're told we have 0.5 liters of solution, but we don't know how many moles of the solute we have. We were given grams. Okay, so our plan is to convert grams of sodium hydroxide to moles of sodium hydroxide. And then we can plug that into our molarity expression. Okay, so what tool do we have? What can we use to convert from grams to moles? Molar mass. So we need to figure out the molar mass of sodium hydroxide. Okay, so we'll do that first, and then we'll use the molar mass to calculate how many moles of sodium hydroxide we have, and then we'll plug that into our expression for molarity. Okay, so I'm going to make some room here so that we can calculate the molar mass. Okay, so if you don't have your periodic table handy, you might want to get that out so you can follow along with our calculation of molar mass. All right, so the molar mass of sodium hydroxide. Okay, so we have one sodium atom, and that has a mass of 22.99 grams per mole. And then we have one oxygen atom, which has a mass of 16 grams per mole. And then we have hydrogen, and there's just one hydrogen, and that has a mass of 1.008 grams per mole. All right, so I'm going to plug this into my calculator. So 22.99 plus 16 plus 1.008. All right, so I get 40.00 grams per mole. Or you might have 39.99. It kind of depends on what your periodic table gave you for the masses. Okay, so now we're going to use that to convert grams of sodium hydroxide to moles of sodium hydroxide. All right, so let's start with the mass of sodium hydroxide that we have in our solution. And we want to get rid of the unit of grams. And we want to end up with moles. So in our conversion factor, should we put 1 mole in the numerator or the denominator? In the numerator. And I'll put NaOH next to that. And in the denominator, we'll put the mass. So 40 grams. All right, so then grams of sodium hydroxide cancel, and we'll be left with moles. So really, we're just taking 6 and dividing it by 40. All right, so I'm going to plug that into my calculator. So 6 divided by 40. All right, so I got 0.15 moles of NaOH. All right, and that makes sense because usually we have a pretty small amount of moles when we're doing these types of calculations. Okay, so now we can calculate the molarity concentration. All right, so remember molarity is moles per liter. So now we have the moles of NaOH, so that's 0.15. And we were already told the liters of solution, which was 0.5 liters. Now, in molarity calculations, this is not a percent, so we're not going to multiply by 100. We're just taking a simple division here and calling it a day. So, what is 0.15 divided by 0.5? Let's see, my calculator tells me that that is 0.3, and I'm going to put in, let's see, how many sig figs should we have? I should have been keeping track. So let's see, we were told we have 3 sig figs for 6.00. For my molar mass, I had 4. Ooh, so my answer up above should have had an extra sig fig there. It should have been 0.150. All right, and then in this part of the problem, molarity, we have 3 sig figs for each given value there. So our final answer should also have 3 sig figs. And remember, we can abbreviate moles over liters as just a capital M. But you could also write moles per liter. That's fine too. Whatever's easier for you. All right, so this is our concentration of sodium hydroxide. Okay, and here are the, oh, no, I do not want to update my carrier setting. Here are the solution slides. All right, and let's do one more problem. What is the molarity of 0.225 liters of a potassium nitrate solution containing 34.8 grams of potassium nitrate? So this is really similar to the previous problem. We're given the amount of solution in liters, and then we're given the amount of solute in grams. So again, we just want to convert grams of potassium nitrate to moles, and then divide that by the volume of solution. So actually, I'm going to have you do this on your own time, and there are solution slides given, so you can double check your work. But just in the interest of time, I'm going to skip ahead a little bit. Oops. And let's kind of summarize all of the different concentrations that we went over. Okay, so the first concentration was the mass percent. And remember, that was equal to the mass of the solute in grams over the mass of the solution in grams times 100. And remember, the solution mass is the sum of the solute and solvent masses. All right, and then the other concentration we learned about was volume percent. And this one, we had the volume of the solute in milliliters, but you could also use liters as long as the units are all the same in your calculation. And then we divide this by the volume of the solution. Oops. Technology. All right, and then we also learned about a mass volume percent. And in this concentration, we take the mass of solute in grams, and we divide it by the volume of the solution. Okay, and then just real quickly, I do want to make the point clear that the mass of the solution for the first two concentrations, let's see, that is equal to the mass of the solute plus the mass of the solvent. And I'll just highlight that there. All right, but in, or I guess the volume of the solution would also be equal to the volume of solute plus the volume of solvent. So you could replace mass with volume there as well. However, in the mass volume percent, the volume of the solution, that is equal to the volume of solvent. So that's just one key point to remember there. So that one is slightly different. All right, and then our last concentration, which I would argue is probably the most important one in chemistry, is molarity. And remember, that was moles of solute over liters of solution. Okay, so we learned a lot in this video, so I think we'll stop there for now. In the next video, we're going to use molarity in calculations. So we're going to use molarity as a conversion factor. And this is a calculation that's done a lot in chemistry. So we'll learn how to do that next time.